Like both parts for 2.
Yeah.
Capital F.
Okay, yeah, we do 4 and 2. Okay, and then someone said 1. Sure, we'll do all 3 real quick. Okay, so for number 1, you didn't have to do like anything fancy algebraic with this. You could have just counted the slope and counted the y-intercept. So from this point to this point, you could have counted, or this does go through the y-intercept. So this is going down 2 to the right 5. Your slope is at -4, so that equation would be y equals -2/5 x minus 4. Questions on that one? Because this is going down 2 and to the right 5. Or if you had gotten 4/10, you would have simplified, it still would have been a negative. Okay.
Is that -4?
Great. For number 2, part A is slope intercept, or was that backwards?
Part A is
Okay. Yeah, we'll do it. So using the slope intercept form, that's just your y equals mx plus b. So this, if you were doing the delta math, it would have showed you this method, but don't do this method on a quiz or test. So this would be put in y equals your slope times x. We don't know what b is, we would solve for that. Multiply 1/2 and -4, and then get rid of 2 by adding it to the other side. So that equation should be y equals 1/2 x plus 5. Now you should get the same thing at the end for b, but you're using your y minus y1 for that one. I'll write that up here. So we're using that point slope for the second one, where this is our x1, y1, so y minus our y1, 3, equals our slope, 1/2, times x minus -4. Or you could go ahead and make that a plus. I'm going to do that. Distribute the 1/2. And get rid of 3 by adding. So you end up with the same thing. Questions on either part A or part B? And then number 4, write the equation of a vertical line that goes through the point 4, 5. So a vertical line is going to be at x equals. Look at what your x value is. Questions on that? Okay. I meant to be passing this off while you guys were looking at this. So I'm going to pass this out really quickly. We're not going to get far in these, but I do want to start them today.
Wait, so for the second question, they're both the same?
Yes, at the end. 1, 2, 3, 4, 5. Take that and then pass it back that way.
Also for n, is that -2.5?
-2/5.
Oh, that doesn't.
Alright, focus!
Today's the 9.
Yes. Okay, so the next thing we have to talk about is parallel and perpendicular lines. Who has heard those words before? Great. What can you tell me about a parallel line? A set of parallel lines.
They never end.
They never touch or cross or intersect. So that's the definition. Lines that never intersect.
That what?
That never intersect or cross.
Why is there 3 eyes? There's 3 eyes on my paper in definition.
It's T actually. That's it. Anyway, moving on. Algebraically. Yes. Danielle is out. Algebraically, we know two lines are parallel if they have the same slope. What do we know about perpendicular lines?
Lines that intersect.
Okay. What were you going to say? Yes. Very specific. Two lines that cross at a 90-degree angle.
They never touch.
Lines that cross at a 90-degree angle. So they make like a perfect T or a cross, but not an X. Algebraically, we know two lines are perpendicular if they have negative reciprocal slopes. So parallel lines have the same slope, perpendicular lines have negative reciprocal slopes. We're going to talk about what that means here in a second. So we've heard the term reciprocal before because we multiply by the reciprocal. So think that, the flipped version. But a negative reciprocal is where one is positive, one is negative. So not only is the fraction flipped, but the signs are also switched.
So it means some positive, some negative.
One will be positive, one will be negative. So it's a flipped fraction that has a switched or opposite sign. Here, can you go over to the board and take that middle white circle? Yeah. Thank you. Now move it up. Perfect. Let's go. Okay, so we're going to do some examples. So if I'm saying this is what the definition of a negative reciprocal is, what would the negative reciprocal of 3/4 be?
Negative 4/3.
What about 2?
Negative.
1/2. -1/2, because all whole numbers are really over 1. And -7/8. Positive 8/7.
2/1. Negative 2/1.
It's already 2/1, so you have to take it and flip it. What about 1?
-1/1.
-1/1, which would just be -1. Now for this one, if I have 0/1, well that's still 0. If I flip it and make it negative, what is that? It's undefined. So 0 and undefined are negative reciprocals, even though they don't look like it. When topic is fine. Okay, so now we're going to determine, are these parallel, perpendicular, or neither? So we're going to find the slope of these both by using our slope formula for both of these sets of lines. So let's do A, B first. Label them if you need to. So that we have 6 minus 3 over 2 minus a negative 2. What is that slope?
Negative.
It's not negative.
3 over
3 over 4. Okay. Do the same thing for CD. So that would be 3 minus 0 over 3 minus a negative 1. What would that slope be? Also 3 over 4. So if these are the same, are these parallel, perpendicular, or neither? Parallel. So you can either write out the word parallel, or this, you'll see this in geometry, is the symbol for parallel lines. Questions on that before we move on? We're going to do the same thing for number 2. Go ahead and find the slope for AB. What is that slope? 2 over 5. And then find the slope for CD. What is that slope? What is that slope? Negative 5 over 2. So these slopes are parallel, perpendicular, or neither? Perpendicular, because they're negative reciprocals. So you can write out that word or put an upside down T. Okay. Now I'm going to show you some neither, neither cases. So let's do number 3. What is the slope of AB? Negative 2 over 3. And then find the slope of CD. One over 4. So are these parallel, perpendicular, or neither? Neither, because they obviously have nothing in common. Now, some other examples of neither, neither are, let's say you had 2 fractions that look the same, but one was negative. So if I had negative 3/4 and positive 3/4, those would not be parallel because one is not the same. That would be a neither, neither case. Or if I had reciprocals, but they were both positive or both negative, that would also be a neither, neither case. So keep all of that in mind. Questions on how we determine that when given points to find slope? Move on to the next one. We're going to do one more of these and then move on to the equations. I'm just re-putting our slope formula just in case you need it. Go ahead and find the slope for AB for number 5. That would be 9 over 0. Okay. And then for CD, not 10. 0 over 3. Now, as is right now, what would we say? Parallel, perpendicular, neither? Neither, okay. Except, if I were to simplify this, 9 over 0 is really what? It's not 9. It's not 0. It's not 3 over 0.
1 over 0.
All of those are going to give you the same answer, which is
0.
undefined.
Oh.
Okay, and then 0 over 3 would be
Undefined.
no.
Oh, 0.
And 0 and undefined would be parallel, perpendicular, or neither. Perpendicular, yes. That's going to be a trick question. So if you see those, keep going so that you know that those are perpendicular. Okay. Questions about that?
Wait, can you explain how perpendicular again?
Hold on 1 second. Yes. No, it's not a negative reciprocal, but they are reciprocals. This is what we talked about. That was one of the examples. That no matter what, 0 and undefined will always cross at a 90 degree angle. Does the line do what? Sorry. So that doesn't matter because that's undefined. That slope is undefined. The 3 doesn't matter because that's 0.
So if a fraction has a 0, it's either 0 or
It's like dividing by 0.
If 0 is in the denominator, you won't get 0. But if 0 is in the numerator, then yes. Okay, now we're given equations. We're going to do the same thing. Are these parallel, perpendicular, or neither?
Which one?
9. Sorry, 9. Why? And what about them? They're the same. So these are parallel because they're the exact same. In general, parallel lines need to have different y-intercepts, otherwise they'd be the same line. What about number 10?
Oh,
Perpendicular, there we go. Because they are negative reciprocals, not just reciprocals. What about 11? Are they the same?
No, they're just moving.
Wait, this door.
Yes.
What would it be if it was just normal or something? It wasn't negative.
Neither. Okay. If we were looking at 12, we would have to solve the equations first. Yes.
If it's neither, does that mean it's also undefined?
No. That those two things don't correlate. So for number 12, in order to find the slope, you have to solve it first. Get this in slope-intercept form. We did this last class. How would I get this back into slope-intercept form? Yes. How? Say that one more time. Not doing anything with that. Not doing anything with this except the y, the x, getting rid of the x. Switching that order so it starts to look like slope-intercept form, and then not subtract, divide by 6. So we have one equation. How would I get y by itself for the second one? Divide everything by 3, because this is basically at this step. So that equation would be at the end, yes. What would this equation be?
Y equals 6x minus.
And yes, these would be perpendicular because they are negative reciprocal slopes. Questions on that? The slopes are reciprocals of each other, and one is negative, one is positive. Okay, we're going to do one more of these. Looking at 16, we have a y equals and we have an x equals, but that doesn't tell us what the slopes are. What is the slope of a y equal? 0. Yes. And the slope of an x equals is.
Y equals 0.
So we're still looking at slope, so not y equals or x equals either, but n equals. It would be a vertical line, but what is that slope?
What negative 1 over 0?
Which is
Which is
undefined. So if we have a 0 and an undefined slope, these are parallel, perpendicular, or neither. So I'm going to draw this as a visual so you see what this looks like. So these would cross and make that perfect T, which is why they are perpendicular. Yes.
Or like so, if you see an equation like that, that y was something, and then x was something, so like that, we have to figure out the slope.
Yes.
And then we figure out the
Yes. Now, if these were both y equals, that would be parallel. Or if these were both x equals, that would also be parallel. Unless it's like one of these and one of these, then those are neither. Okay. Other questions about that? Ladies, focus.
Wait, so in number 5, like above, there wasn't like. So does it matter if they negative or not?
You talking about this one, this one. Oh, this one. No, it doesn't matter if it's negative or not, because this will always simplify to undefined, and this will always simplify to zero.
Wait, for number 6, how'd you get n equal to?
Your Hoy-Bucks. Horizontal lines always have 0 slope if they're y equals. Other questions? So delta math on this is due next week, but we're gonna keep going. Actually, I want you to try 2. Try 15 and try 14. Are those parallel, perpendicular, or neither?
Neither. Oh, sorry.
They're parallel because they have the same slope. Are 15's equations parallel, perpendicular, or neither?
Parallel. Neither. I can make it either.
Well, by process of elimination, yes. But why are they perpendicular?
They're wrong.
If you graph them, first.
So it's the slopes. The back of the slope.
Because the
So
slope is
yeah,
different.
Okay, go to the science or the business. Yeah.
Wait, for which one?
Rows. Because the slopes are opposite, they're negative reciprocals. This is 1 and negative 1.
Wait, can you produce
So after you solve both equations and look at the slopes, they're parallel. Brennan,
So, what's the first step for 14 minus 3?
get rid of the x term for both. I just did it simultaneously. Get rid of the x term on both equations. Yes.
So if it was 1 and 1, it would be parallel.
Yes. Okay. Or if it was negative 1 and negative 1, it would be parallel. Yes. Other questions? Debating. This page is strictly for if you want extra practice, you don't have to do that. We'll do one of these in Q1 because we'll finish it next class. So part of what we have to talk about with parallel and perpendicular lines is, can you determine if it's parallel or perpendicular or neither based on slope, based on equations, based on graphs, which that would be you counting the slopes. Another part is you're going to be given some equation and given a point, like with writing, you were given slope and a point, and you're going to have to write another equation that is parallel or perpendicular to the original.
I was gonna switch. So that's fine.
So this is just to keep those in mind, that parallel lines have the same slope. Perpendicular lines have negative reciprocal slopes. Okay, we'll do one of these, and I want to show you how to check yourself in Desmos. So in this, I'm given some equation. The only thing I need from that is the slope. I can cross out the y-intercept. I don't need that. It will only confuse you. Then, if this is parallel, I know the slopes are going to be the same. So I know it's going to be the same as -4. I'm just going to write that as I have it, so I have it for later. And then we're going back and we're going to use our point slope. So I will rewrite what that is one time. You also have it on your quick check. The same thing we just did on the quick check, yes. So then once you know what your slope is, you're given a point, x1, y1, and you're going to put that point and the slope in your point slope formula. So y minus 7 equals -4 times, I'm just going to put +2, but it would be minus minus, which became a plus, and so on. So distribute. And get rid of 7. What is that final equation? So if I'm comparing that to the original, this was +1. I see the slopes are the same, so these would be parallel because they have the same slope and different y-intercepts. We'll talk about how to do the rest here in a second. So as you start practicing this on Delta Math, because it would have been minus minus, which changed to a plus. I just went ahead and did it as a plus. One of these things and how I did myself before I thought I did. If you need to see this again while you're practicing at a later time when you start to practice, I can show this again. Home screen, but it's not there. Okay. So it kind of works the same way for parallel and perpendicular, and I'll re-go over that part. But for your writing, if you have some point, let's say for your quick check, you had the point -4,3, I'll put that in. And we know this has to be in y equals mx plus b. It's going to ask you to add in sliders. You're going to add in all. If you know your slope, so like in the quick check, you knew your slope was 1/2, so I can change that to be 1/2. And then I can move my b until it goes to this point. So that way I know my equation would be y equals 1/2 x plus 5, which it was. So that's a great way to check yourself. That works for all of your equations to include your parallel and perpendicular. Okay. I'm going to let you guys grab phones early today just because PSAT was long. But remember that you do have 2 Delta Math due on Friday, the writing